Hello and welcome to another video with Leah. Today I'm going to be talking about wavelength and frequency as it relates to chemistry. I'm going to give a shortcut for these equations, and I'm also going to do a few practice problems so that you can see how this works. I really hope you enjoy this video. And if you're new here, remember to hit the subscribe button and comment down below. Here is an important equation for these problems. So C equals lambda times nu. Lambda and nu are Greek letters. C equals the speed of light, wavelength is lambda, and frequency is nu. So when we see this equation, we can say that the speed of light equals the wavelength times the frequency. And from this, C equals lambda times nu, we can also set the equation equal to wavelength or the equation equal to frequency. This is what it looks like. So we can say that wavelength is going to be equal to the speed of light, c, divided by the frequency, nu. We can also say that the frequency is equal to the speed of light divided by the wavelength. And in this case, the speed of light is going to be 3 times 10 to the 8 meters per second. Now, instead of writing all of those equations down, c equals, lambda equals, and frequency equals, well, we can just write a shortcut. We can just put it like this in the circle, and remember that c is going to be in the top part. Now the way this works is that if we cover one of the variables, let's say we cover c, because we wanted the equation for that, then we are left with lambda times nu, so wavelength times frequency. We could also cover the frequency if we wanted to find frequency, and therefore frequency would be equal to the speed of light divided by the wavelength. And lastly, we could cover wavelength, so that wavelength we can see is equal to c over nu. So in this shortcut, you just cover the one that you want, and you see what's left. And what you see left is going to tell you whether to multiply or divide. Now let's do some practice problems so that you can see how this works. When frequency is 6 times 10 to the 5 seconds, what is the wavelength? Alright, so we'll just go ahead and cover the wavelength because that's the equation that we want. And so we are left with wavelength is equal to c divided by nu. Now c we know is 3 times 10 to the 8 meters per second. And frequency is 6 times 10 to the 5 seconds. Seconds cancel out, and we are left with 500 meters for the wavelength. The wavelength of blue light is about 450 nanometers. What is its frequency? Alright, so now we want frequency, so we'll just cover up frequency. And that will give us frequency equals to speed of light divided by the wavelength. We know that the speed of light is going to be 3 times 10 to the 8 meters per second. And we also know the wavelength. However, the wavelength is given as 450 nanometers, and the speed of light is given in meters. So we can either convert this many meters to nanometers, or we can convert this many nanometers to meters. We just have to make sure that when we put the numbers into this equation, that they have the same unit. So let's go ahead and convert nanometers to meters. To do that, we know that in 1 meter, there are 10 to the 9 nanometers. This is the conversion given by the SI units. Okay, so now nanometers is on the top and bottom, these units cancel out, leaving us with meters. And this is going to be 4.5 times 10 to the negative 7 meters. Now that we have meters as our wavelength, we can plug that number in. Meters cancel out, leaving us with seconds. When we divide these two values, we get 6.67 times 10 to the 14 seconds. Alright, so this problem just required us to do one extra step, which is to make sure that when we plug in our values in the equation, that the units are going to be equal. Find the wavelength of light that has a frequency of 62.4 megahertz. And here's a note that we need to convert megahertz to hertz for the equation to work. Alright, so we need to find wavelength, so we'll cover up the unit for that. So wavelength is going to be equal to c over nu. We know that c is equal to 3 times 10 to the 8 meters per second. And our next note is to convert this many megahertz to hertz. Now mega is just an SI prefix, so we know that in 1 megahertz, there are 10 to the 6 hertz. Alright, and now we can cancel out this unit, leaving us with 6.24 times 10 to the 7 hertz. Okay, so now we can just plug in 6.24 times 10 to the 7 hertz. Okay, and seconds are going to cancel out here, leaving us with meters. This is going to be 4.81 meters.